Hey, what is up, guys? This is my first video ever. I kind of like the idea of working in public, and I'm just transitioning from finance to mathematics, and I'm just doing some pre-calculus course 2 stuff, and I thought it'd be a good place to start. So yeah, let's dive in. You should be able to see my screen. This is from Oregon State University. I'm just taking it over this summer of 2024, and the only thing I've done is a brand new course. I just finished up the pre-calculus course 1, and I'm just writing out the learning outcomes that are expected after each chapter, as well as like a brief summary of how the instructor describes the chapter. Now I know you won't be able to see this. I am working on getting like a video that will go right here, but I thought I'd just start recording now, and then when we actually get to the workbook and math practice, I'll start speaking out loud, which will help me too. So these videos might be a little quiet for the first part, but you know, here's to a new beginning. So cheers. So I'll start my Pomodoro timer. Well, I was doing it for like 10 minutes, but this was actually a bit of a distraction getting this going. But now we're back into it. 50 minutes. Okay, I guess this is really laggy. Granted, I'm running off not a shitty, but a Lenovo ThinkPad. So there's only so much you can ask of this bad boy. Nice. All done. Okay. Let's see. Next on the to-do list. Oh, this is the best part. We can cross it out. Okay. Okay, next on the to-do list is Module 2, Investigation 6 Workbook. Now, I ordered the workbook in the mail, but he's been kind enough to provide it online, and so I printed it out. But before that, I wanted to just kind of read this over to myself. The learning outcomes and summaries, just to solidify it one more time. What I could be expecting in the course, so and I can read it out to you too, so you guys will know. So we have Pre-Calculus 2. Let's see, there's 5 sections, and each section is 2 weeks long. So section 1. Great summaries, by the way, this guy. I'm actually really liking this guy because he just seems, like the kooky mathematicians, and I like that. As I'm transitioning to try to become technical, the people that are kooky seem to know the most, and they're always just fun, and they really know their stuff, and they explain it in really succinct, beautiful ways. So I actually really come to enjoy them. But he says you will learn the connection between circles and the Pythagorean theorem, as well as reviewing functions. And he says later trigonometric functions. So learning outcomes. After successful completion of section 1, you will be able to 1. Estimate the radian measure of an angle. I don't know what a radian is, so that'll be fun. 2. Calculate and or estimate the relevant variables and relations in a mathematical setting. Bar just means applying it. Which I actually have been really looking forward to. Convert from radians to degrees using proportions. Don't know how to do that. That should be cool. 4. Calculate arc length. Don't know what an arc is. 5. Identify situations that can be modeled mathematically. Sounds cool. 6. Model with trigonometric functions. Nice. 7. Graph sine and cosine. 8. Use sine and cosine to determine coordinates. Sounds interesting. 9. Formulate and solve problems using the polar coordinate system. I don't actually know what polar is. Cartesian, I assume he means Descartes. Made by Descartes. But polar, is that like imaginary? But who knows? So we'll see. Distinguish between radius lengths and conventional units. Understand the equation of a circle and distance formula as the Pythagorean theorem. This is something I'm going to post on the discussion board, but I found it interesting how... Oh, we haven't gotten to it, but I'm going to ask, why is the circle so fundamental? And it seems from the descriptions he's given from these summaries, why is it what the trigonometric functions have arisen out of? Right? Like, why not a rectangle? Or why not a square? Like, why is it, if I remember anything from pre-calc in high school, like, why is it a right triangle in a circle with a radius of 1? Why does that lend itself to trigonometric functions? And why, maybe not why, it's probably hard to answer, but isn't that crazy that trigonometric functions, from what he's described, are just periodic motion, is so applicable in nature in describing, and just all from the circle. Okay. Section 2, you will have now built a strong foundation based largely on the circle. Dive into the relationship between angles and points on the circle. Oh, here's where he talks. Imagine a point on a circle is moving clockwise. Better yet, think of a clock. The minute the head goes around, and after an hour, it starts to repeat its position. That's periodic motion. You will learn to use new functions, sine and cosine, that behave in this fashion. Those functions form a cornerstone of mathematical modeling for people of all levels. Right, another question I have for him. Don't you like? Is there a way to? Are all trigonometric functions? Are all trigonometric phenomena actual functions, and specifically satisfying the criteria that a function has one input to any number of inputs to one output, but there can't be one input going to two separate outputs. Yeah. Notice the learning outcomes of section 2. Model sinusoidal phenomena with trigonometric functions, solve equations with trigonometric functions, critique the applicability of a mathematical approach or the validity of a mathematical conclusion, model with trigonometric functions, and model with inverse trigonometric functions. Section 3, the very important topics of section 3, tangent function and the inverse of each trigonometric function. Tangent is a slope. Sounds familiar from the 3 blue 1 brown on calculus, because he always says like tangent when he did like that moving straight line. That's all I remember though, what a tangent is. Learning outcomes. Maybe I'll just say out loud the only ones that sound interesting. Calculate and or estimate the relevant variables and relations in a mathematical setting by measuring the angle of elevation and using it to determine the height of the tree. This will be assessed in the Project 3 write-up in an online homework. Project 3, I'm pretty sure it's going to make me go outside, and that's actually interesting. Like, seeing it physically applied to the tree outside my apartment complex would be dope. If it predicts accurately. Model with trigonometric functions and model with inverse trigonometric functions by constructing a function relating angle measure and two distances. The constructing a function relating angle measure and two distances sounds interesting. Critique the applicability of a mathematical approach. If it helps me apply math in the settings, then yeah. Okay. Section 4. Learn to determine the measure of each angle and the length of every side in any triangle. Learn strategies for breaking triangles into right triangles. Learn Kepler's method for determining the distance between planets and the sun. Sounds cool. Yeah. Make use of the law of sines and cosines. Don't know what that is. To solve oblique triangles. Don't know what oblique is. Besides, it's a different triangle. But so that should be interesting. Use identities to solve simple problems. Section 5. You will learn to describe vectors in both Cartesian and polar coordinates. You will learn to take a velocity or force and construct a vector to model it. You will learn how to obtain the magnitude and direction of a vector from coordinates and vice versa. That last part sounds interesting. Convert vectors into polar forms and into Cartesian form. Apply the trigonometry of right triangles to relevant problems. That's cool. Granted, mathematicians definitely know how to make things sound complicated. And so we'll see, but them sound interesting. I might take a little break now and just talk to you guys. I already know this is the right decision. It feels so good to have you here. It's like a study buddy almost. It's weird knowing that you're recording. You guys will see this. It's just accountability, making me do it every day, and just kind of reassuring. I don't know. It's weird. I said my name, said why I'm doing this, where I'm coming from. I want to eventually get into software engineering. That's what I just applied to Oregon State for my second bachelor's to do. My first bachelor's was philosophy, and I was working, and yeah, I want to do software engineering, and maybe, I think, machine learning, specifically applied to math. I think that could be really cool. So I'm doing a second degree online, um, you know, while working full time, and then I'll, yeah, goal is to get a FANG, specifically Meta in New York. I think that'd be really cool. I haven't lived in New York, and I think that could be really dope. So fingers crossed. But I'm just starting the journey. I just got accepted to the CS program for this fall, so this should be fun. I think I'll talk now about why I'm doing this a bit more. I said working in public, but there's two other reasons. One, I hope once I actually get into more than introductory technical courses, that it'll be a boost to my resume. It'll be great for networking. Other people can see me work in public and really know that I'm not some chump. So it'll help from anything when I cold email to, people might find me and we can find like-minded people and just interact. And I think that's really cool. And I'm always looking out for interesting people to talk with and learn from. So I think this is such a great avenue to do that. Because there's been times where I look at someone's online blog, and it's such I read it somewhere on Twitter, it's like a one-sided relationship, at least temporarily, hopefully, temporarily. But you feel like you have such a good idea of that person just from kind of stalking them, on their blog and just inferring things, and you feel a lot more comfortable, like if they reached out to you saying, hey, I want to chat, or hey, I need a job, you would feel a lot more comfortable, and that's really appealing. And two, and this is, um, it, I'm displeased at the fact that there's a lot of overstatement of what really any work actually is like. Be like, oh, someone will be like, oh, I worked so hard yesterday, or maybe in a technical manner, engineer to engineer will be like, oh, he's so smart, um, and I find, I'm really leaning towards the argument that really hard work, you know, great mentors, a great community, but really, good hard work, putting in the hours at technical, no matter how smart you are, you will eventually get to where you want to be in terms of technical understanding. And I think this overemphasis on intelligence, which determines the speed of the acquisition of your knowledge and technical skills if you're doing technical work, is really harmful. I'm 25, but it still kind of lingers with me, and I think for a lot of young people who are unsure of what true work looks like, and they're determining, what they want to do with their careers, I think it's extremely harmful, and I think it really maybe, who knows, but it might, push out people that otherwise would have come into any technical field, because they think, oh, I'm not smart enough, and almost, at least in my experience, I've actually, when you quiz someone that seems, intelligent, I mean, that's, is put on a pedestal in a technical field, they just put in the work, Yeah, they might be smarter, but you could get there too. And sometimes, this person's smarter and they're working less hard, and if you put in more work, then every single day that will compound and you might beat them, maybe, and I just think it's, I want to be like an inspiration. Sounds a little grandiose. I just want to show people that, like, what just putting in the work can really entail and really get you towards, because I didn't want to start, if I was going to follow how everyone else is kind of doing this, I would only start these videos when I got to like real analysis of math, or like or like the compiler of the coding classes, and then I'll seem all smart like out of the blue. Like I didn't, but I want to show like I don't know shit. And I think it can be a journey for both of us, and I think it can just be cool to show people. Yeah, I think you get the memo. So yeah, I just didn't feel right to have that long portion at the beginning. I just thought, I'll just dive in. Even though it was probably a little disturbing to have that kind of intro. I don't know, I think, let's say 35 minutes into the video instead of at the beginning. I should point out that, I'm a little selfish. That's the one charitable reason I'm doing it. And I hope, if you can gain technical insight out of this, that's great. But I'll be honest, I'm not trying to become a full-time influencer. And so the aesthetics of, it's like where I upload, I think I'm going to upload this to YouTube. It's not going to be clean. I'm not going to, put a lot of work, like let's say 3 blue, 1 brown, to make it really easy to understand. No offense, if it's helpful to you, great, but I'm not going to put a lot of work into it. It's more for me. Sorry. So I want to let you know that. Yeah. Yeah. So I'll talk out loud because it kind of helps me, and of course I will do a little work, make it understandable, because I want it to feel like a conversation. But I won't like craft like visualization software or to help explain the math, or probably. Well, yeah. So I think you get the gist. Okay. I think that's what I wanted the intro to be. So yeah, I'm starting at Pre-Calc. You can kind of tell that I didn't pay attention during middle school and high school math. I just remember bits and pieces. So this should be pretty inspiring if I can get to some higher level math just by hard work. So I will. But okay. Let's do it. So we're onto the workbook. This should hopefully be a little more interactive. And by the way, maybe I should explain my background, so I don't seem like a slob. I usually do make my bed every morning, but not this morning. And that black rug is to keep out the light. I'm just really light sensitive when I go to bed. And it's just nice going to bed early, even though right now it's the height of summer, when it gets dark at like 9:30. But I can go to bed at 8, and that means I can wake up early, which I like to. Nice painting. Yeah, that's a personal development paper I put up there. Hopefully you can't read the actual text. That'd be a little much for me. But it's actually nailed in, so I was like, I am pretty proud of it, but I'm just hoping more so you can't read the text. And you might see a bit of clothes. It's just workout clothes I put there every morning. So I can just easily grab it, but it kind of looks like a mess. So I apologize for that. Okay. Yeah, you know what I could do, even if I don't have the video? I could just pull up the digital one for you guys. Right here. Here we go. Is that working? Yeah. Oh boy, this is really putting my Lenovo to work. Actually, I didn't mean to bash it. It's actually the best Mac. Used to have a Mac. It's the best PC laptop I've had ever. It's just great battery life, great like intuitive feel, great keyboard layout. Just good stuff. And it's sleek. Okay, you guys can see this. Okay. Okay, so I can't be further than 3.5 miles. What quantity do you need to find to determine if you will have good reception at the house? Illustrate these quantities on the figure below. I assume it just means drawing a line between the house and the cell phone tower because, distance in real life the cell signal is not like literally going like south and north, like following this grid. It would just be straight. So what quantity do you need to find to determine if you will have good reception at the house? If good reception, illustrate. Okay, so I've illustrated. I would say distance between the house and cell tower is needed. Must be complete is needed to determine if I will have good cell reception at the house. Determine the distance between the cell tower and the house. Well, okay, I remember SOHCAHTOA. Oh, anyway, I was about to do like right triangle, and then like plus a mile, and then calculate the two hypotenuses. But I can probably just like I probably don't have to. Probably just normalize 19th Street, 19th Avenue, which is the bottom, as 0. I probably don't have to count like 20th Avenue as 20. So I can just write A Street is 1, B Street is 2. So I'm just going to make this a graph. C3, 4, 5, 6, 7, or 6. Okay, yeah, I think. Yeah, okay. And then I'll just make 20th 1, 21st Avenue 2, 22nd 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, okay. It's a straight line. So I can just do I should know that just so y equals mx plus b. I know the slope formula. Oh, draw a triangle down. Just one big triangle. Okay. So the bottom, like this. Should have seen that. Boom, boom, boom. Okay. Oh, okay. So the bottom 2 to 4, so that's 2. We need to find the hypotenuse. The long side is 1, 2, 3. Okay. A squared plus B squared equals C squared. I think. A squared plus B squared. I think that's it. So, Toa. That's for angle over. Oh. I think it's A squared. Okay. Okay. A squared plus B squared equals C squared. Wait a minute, so. So, opposite over hypotenuse now. I think you need the angle to like it. I think it's A squared. Okay, so A squared. Does it matter if which ones? Okay. 2 squared plus 3 squared equals C squared. Okay. 4 plus 9. That's okay, interesting. Equals C squared. Equals C squared. Okay, 4 plus 9 is 13. Okay, square root. Okay, so C equals the square root of 13. I mean, I just think that'd be surprising if, I feel like at this level they like to keep things simple. I doubt the answer is a square root, but, and it's such a weird number. Like it, maybe if it's simplified, but, I feel like I am allowed to look it up, but I don't want to. He emphasized doing the workbook first. So I want to let you know, I haven't read the notes, I haven't read the lectures. He said, try the workbook first, all of them. Do the graphing activity first. Then just post on the discussion board or email him. He was like really open to questions. He's like, don't even look online. I think he's trying to keep it self-contained. So I was like, this is an interesting way to go it. Let's do it. He's like, you'll get further than we think. And then do the online homework because there's infinite tries. And then finally look at the notes if you're still having trouble. So I guess we can leave it to come back to determine the distance. Well, let's try the SOHCAHTOA. I think that requires an angle. SOHCAHTOA. Alright, so what it's saying is sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So if I'm trying to find the hypotenuse, sine. So what? Sine of 90 degrees equals opposite. Oh no, because opposite of 90. See if I drew a little 90 right here, because it looks like a right triangle. What about a G? No, I think what it's like the degree of cosine is opposite over hypotenuse. Yeah, like the angle. So, like if it was here, like if the sine angle was here, like this is the angle you want to find. Yeah, you would do like 3 opposite divided by hypotenuse, whatever it is, and that would give you the sine of the angle, or maybe just like that angle. I don't know. Okay, I'm gonna stick with square root of 13. 4, okay, 2 squared, 4, 3 squared, 9, 13. Okay. Find variables that can be used to describe the distance of any house. Define, I don't know what he means by define variables. Does he just mean it's not all distances? No, actually. Not all distances. Are all distances going to be a right triangle, therefore allowing a squared plus b squared? I mean, like, interesting. Actually, it kind of looks like that. We have trying 22nd and 0 right now. Backward. There still seems to be a space for 90, which I think is the rule for right triangle. Yeah, I'll put as a in this grid context, a squared plus b squared equals c squared. Use the variables defined in C to above to define a formula that represents the distance. Define variables that can be used to describe the distance of O. I think he wants me to describe, like, define A, B, and C. Describe the distance that can be used to describe the distance. Use the variable defined in C above to define a formula that represents the distance of any hint. Use the Pythagorean theorem as a starting point. The starting point? I thought it was the answer. What the? As a starting point. What? As a starting point? Okay, well, one, I jumped the gun in C. He's not. Next, D should be this answer. Yeah, this C answer should be in D. So, okay, so I'll write it down in the D. In this grid context, a squared plus b squared equals c squared. Now back at C, I'll say a equals, I'll say one side of triangle, but then I'll apply it to here in this grid context. B equals other side of, I should say right triangle probably. One side of right triangle, other side of right triangle. Okay. And C equals, so you'd say, longer side of triangle, but then I'll apply it. Longest side of triangle. Okay. Now put it in this context. Longest side of triangle, and in this context, line from house to cell tower. A. Okay. I mean, does A have, like, I feel like either sides of the triangle could be A or B, I think. So it feels weird saying A is the horizontal distance and B is the vertical distance. Okay, whatever. A equals vertical distance from house to cell tower. God, this is a mess. B equals horizontal distance from house to cell tower. Okay, now I'm moving on to D. Use variables defined in C above to define a formula that represents the distance of any house from the tower. Oh, maybe he just means square root of C. Because C squared is obviously not the answer of the distance. So maybe he just means so C equals the square root of A squared plus B squared. I think I'll put that as the answer. Another cell tower is located at some point. X1, Y1. Define a formula to determine the distance of any house from that cell tower. I think it's the same. That's clearly not. Maybe. Okay, why would he be asking this? I feel like I've completely missed like the train of thought that this workbook is supposed to have me on, like the path to the eureka moment. I feel like I've completely missed it. Other cell towers located at some point. Define a formula to determine the distance of any. Well, why wouldn't it just be D from what he said? That represents the distance of any house from that tower. The only difference is he's saying distance of any house from the tower, and here it's saying to determine the distance of any house. Oh no, same thing. I thought that E was saying distance of cell tower from house, but no, it's the same. So the only thing that's changing is the cell tower location, because in the first one he's saying any house from the tower, the 23rd and D Street. And in E, he's saying it's a different one. But I feel like due to the grid, it's like look. Okay, let's say it's here. Well, actually, if it's here, oh, interesting. If it's on the same line, it's actually not the A squared plus 1. No, because then there's only one variable. It's just the distance. That's interesting. So, but if it's anywhere else, look, like right here, let's say the cell tower is right here, then, look, it's still like a right triangle. Boom, boom, boom. See? Hope you saw that connect. Or like, let's say it's all the way down here. Here, look. Boom. Because it's on a grid, it'll always be able to meet it. And let's say it goes over here. No problem. You just flip the triangle, but it's still, you can see how that's like a right triangle right there. Now, ooh, that's a good point. So if it's on the same horizontal thing or vertical, vertical, then it's not. Now he's saying, use the variables defined in C above to define a formula that represents the distance of any house from the tower. Well, I don't get how I'm supposed to. I feel like I should have two equations. One is if it's not on the same horizontal or vertical thing, and another one for if it isn't. And if it's on the same horizontal, well, you describe it differently. Just how many steps right did you take, since each step is 1 mile? And if it's up, how many up or down steps? That's a mile. Well, he said to try it all I can, so I feel like I've spent a lot of time on this. So I'm gonna leave. I clearly did not get the memo here, so I'm gonna leave C at E as a question mark. I don't want myself to be wrong. I'll just put C. Even I know. Fuck it. A squared plus B squared equals C. They say best mathematicians are one that stick with the problem. Just a bulldog at it. And I have clearly not done that. Maybe there's no hope for me. Alright. Now, well, actually, it's kind of printed out very foggy on the paper. Consider a cell tower at the location -2 4 on the coordinate plane with the coverage radius 1, 2, 3. Okay. Note that every point 3 miles away from the cell tower will be on the boundary of the cell coverage. By definition. That's cool. And I just realized that it's not only it's not only the 3 miles away from the cell tower will be on the boundary of the cell coverage. That applies to more just than the very obvious ones that are like up, left, down, and right. Because by the definition of a radius, it's the center point to the boundary. That means if you just rotate it, it'll always be 3, so that you don't have to do some like complicated. Oh, actually, it's just a triangle. You find the hypotenuse here. Yeah, you can see that. Okay. You don't have to find the hypotenuse. You can say it's 3. That's actually cool. Okay, so this will form a circle around the point with the radius. Okay. At point A point x2 southeast of the tower is on the surface boundary. What must be the value of x? Okay. He's saying 2. It must be 0. Well, actually, 2's looking a little bit above. 1, 2. 2's looking a bit above where the line is actually crossing. Like, it looks like the line's actually crossing right below 2, maybe at like 1.9. I'm gonna assume that's a printing error. Southeast on the surface boundary to line, what must be the value of x? Oh, I don't know why, it didn't matter, because either way, the line that's touching the line is going to be 0. X equals 0. Let x, y be any point on the surface boundary. Create a formula that represents the distance of any house from the cell tower. Okay. Represents the distance. Represents the distance of any house from the cell tower located. Clearly define any variables you use. Damn, this guy's just... Dude, I do like it. I like this. Okay, well, if it's on the inside, can it still be a triangle? And if it's on the same line, it seems like it's just... There's no 2 variables to calculate this. It's just 1. But when you get 2D, it looks like here, then yeah, like here, this big triangle. Yes. Oh, on the surface boundary. Let x, y be any point on the surface boundary. Create a formula that represents the distance of any house from the cell tower located at feel like there doesn't need to be a formula. If I'm reading this right, he's saying all houses, which is any houses, will be on XY. But he's saying it'll be on the service boundary. And from up here, we know that the service boundaries always has a radius of 3 miles. Radius is just the distance in this case. So I guess the formula can be, D equals, include units, 3 miles. So define any variables. D equals distance to cell tower from house. Maybe I'm missing something there, but seems like that's the answer. Oh boy. Feels like the ACT. Oh. Okay, so I'm on to Module 3, Investigation 1. Hopefully closing some of these tabs. Oh, I shouldn't have done that. That was... Here we go. Oh, that's online homework. God, this is so laggy. Okay, Module 3, Investigation 1. Damn. Okay, how much longer do I have? Jeez. Oh, motherfucker. I fucking stopped the timer. What? I thought I... Okay, no wonder I was getting tired. I'm probably dead, like... Alright, I'll do this one. I'll let you guys go. You can see this from me. Okay. Motherfucker. Do like math, but... Consider what is involved in building a box. Without a... Oh, I hate it. Okay, I can't even build a box in real life. On the top, 11 by 8 with 5 by 11 sheet of paper by cutting squares from each corner before you decide. Okay. To understand how the quantities in this situation are related, it is important to first model the situation between the following. Cutting 4 equals sized square. Fully with the size. Okay. Do the cutouts have to be a square? That's interesting. No, maybe just equal. I assume he means do the cutouts have to be a square to make a box? What quantities in this situation vary? Damn, this is okay. Like how applied this is. Okay. Scissor. Scissor. Okay. Okay. I just ordered this for this class. This should come in handy. It's a little ruler. I guess I'll just do 2. I'll do like 3. It's actually a lot. Do like 2 inches. Yeah. Oh, how am I supposed to know? Two's like here. Okay. Mark where 2 inches across is. Okay, it's like a bit more. Okay. I'll mark where 2 inches high is. Hope for the best. It's like cut. That part doesn't have to be that exact, but oh, too low. Okay. 1 to go. I mean, 1 down. Okay. 2 over. That's right here. Oh, that's way too high. It's not correct. Okay, right here. Okay. Should be a good exercise. Maybe increase my mechanical, like physical, putting parts together. Oh wait, intelligence. 2 more to go. Okay. 2 inches high. 2 inches high. 2 inches across. Okay. Curved or angle. Fuego. Okay. Let's see if I did this right. Okay, so fold this crease. Okay. Fold this crease. Also fold this. Maybe I should have put this long one first. Fold this at this crease. Fold this at this crease. I'm gonna make that tight. Okay, let's see what we got. Okay. You know? This is explained moving boxes a lot more to me now. Ta-da! Looks like my own little bento box. Okay. Oh, I have to tape them. I will not be taping them. Do the cutouts have to be square? That's my question. Might have to try. You know what I can have to do this again. So what, like make it's a rectangle. Well, I think the intuition is, well, no, but all of the cutouts have to be equal of the area taken out. know it's triangle, okay, like a rectangle. So 3 tall, 1 wide. Yeah, okay. 3 tall. 1 wide. 1 inch. Okay. Okay, so now I'm here. This feels weird. 3 tall. 1 wide. Oh. Okay. 3 tall. 1 wide. Yep. There's this one. 3 tall. 1 wide. That's right, I think. 3 tall. 1 wide. Okay, got it. Okay. She really got me. A little sus out. I don't know about this one. 3 tall. Huh. Yeah, I feel like this looks similar. They're kind of bad. Yeah, like that. Okay. So you guys can see, like, I did it right, like, oh, okay, I'm not good at this video thing yet. 3 tall, you know, because it was like this. So 3 tall, 1, and then I flip it here. 3 tall, 1. 3 tall, 1. 3 tall, 1. Okay. Can I make a box? I feel like a circle could have worked though, right? Like, what if I do like a circle? I can do that now. Really fill in. How the hell am I gonna fold this? I feel like I can do this. Like crease here? Oh no. I should crease more, right? Yeah, I feel like I would just crease at different boundaries. Okay, so I'm gonna crease this. It's very thin. Crease this. So you can probably imagine there's like weird corners like this. And there's the limiting factor. So I just folded it that limiting factor crease. It kind of looks like there's holes in it. There's many holes in it. Oh, there's many holes. But like, I did. I think the definition was for a box. Oh, you know what'd be interesting? If the holes were 1 inch. No, they're more like 1 3/4. 1 3/4. 1 3/4. There's a pattern. There's something going on here. 1 and 3/4. 1 and 3/4. Interesting. It's an interesting question. I'm gonna write that down for him. Okay. Actually, I'm gonna put it right on this one. Why is gap 1 and 3/4 inch? Okay, I'll split the dimensions. Rectangle cut out 3 inch tall, 1 inch wide. Now I want to try that curved one. I feel like that could work. Luckily, I won't have to mark anything. Okay, I'll just probably start at the same spot, but fuck it. I'm not an artist, that's for sure. But I could if I wanted to be. If I put in enough practice. Then I could be beautiful artist begging at Starbucks. Well, these are not really curves, but I think it gets the point across. I'm just saying. Okay, so not my most beautiful, but let's see what we got here. Yeah. Interesting. Actually, it's looking like all the points are folding over, which was the same with the box. But we'll see. But this is interesting. All the parts are folded over. Now let's open it. Huh. Well, I'll be damned. Interesting. Granted, that was such a shitty cut, too. Huh. Yeah, I mean, I guess the definition is the box. Like, this first one, has, up here at the corner, there's no loss of area. There's no really wide openings. Here, Jesus. This light is, okay. Here there kind of is. But that just might have been the shitty cut. But it's the box. Okay, so that original hypothesis seems to be holding. No, just the area of the cutout has to be this. Oh! No, because my rectangle didn't work. Maybe the distance in, the width, and the length of the cutout have to be the same. Of all the cutouts, you know what I mean? Like, as in, any one cutout, the length has to equal the width cut out. So if it's 1, it's 1. It can't be 3, 1 like I did. But, oh. So that's a square, except when it's a circle. I mean, a curve. So, would a triangle work? Like if triangle looks like it's work. But why is it square? It's only a square if it's 90 degrees. I could test the triangle. I could. So I'm going to write no. How did I do? Was that a curve? A curve cut out works to the width cut must equal the length cut for each corner. So often a square, but not necessarily. That's not right, but what quantities in this situation vary? What quantities in this situation are constant? Vary. I guess you could say the area cut out, because you can do 3 by 3, which is 9 square inches, versus 2 by 2, which is 4. Okay. Area cut out, not dash, vary, and the constant. What quantities in the situation? How would you describe it? I would think that if you cut out, say, no, because I showed here. Yeah, I would think that if you kept the area that you cut out at each corner equal, then it would work. I just showed here that that's not the case. But maybe I did it in the wrong order. Like maybe by going 3-1, I should have done 3-1 and then 1-3 when I turned it. Like, and then maybe it would have worked. The quantity is the relationship between the length and the width. Okay, I should say area cut out per corner. What situations are constant? Area cut. It's not area. Area cut out, but then like the whole. Like. What situations vary? Length and width cut out. How do I put this? Area cut out, not vary. Total area cut out. No, that does vary. Oh, Jesus. Okay, I'll say length and width have to be equal, but they can be any number. I should say any number constrained by the size of the paper, but I will not. Actually, I will. Constrained by size of paper. Okay, does not vary. Okay, each corner must have an equivalent area taken out. I wish he said quantity. Answering, describe how the configuration of the box changes as the length of the side of the square cutout varies. Describe that. Okay. You know, I'm gonna ask how to phrase this on the discussion board. How to phrase this on discussion board. Okay. And left off on D. Well, this was fun. All right, peace.